Okay, on this lesson, we're going to be looking at quadratic regression. Instead of linear regression, we're going to look at quadratics. So this first part, it says quadratic regression may be used to formulate the equation of quadratic functions. You need at least 3 points So at least 3 points are needed to formulate the equation of a quadratic. Remember, on linear, at least 2, so it's different for every regression that you're talking about. So the quadratic regression equation will be written in this form. Remember, quadratic has an x squared. We've discussed a, b, and c before. So you're going to be looking for a, b, and c, and then you can plug in and write your quadratic equation. So points can be found from graphs. So if you're given a graph, you can find the points. Tables, sometimes you'll be given a table, and descriptions. So sometimes you have a word problem and you're having to set up that table. It is best to use all the data provided to ensure a model with the best possible fit. So even though it says at least 3 points, you want to use all of the data that's given to you to get that best fit. Okay? So example 1. We're using regression function on the calculator for quadratic in order to find it. So we're going to go first off, let's review real quick on what we need to do in order to get that R turned on. So if you remember to do that, you're going to do second and then the 0. You're going to go it's diagnostic, so you go to D's. And it's diagnostic on. Press enter, it should say done. Okay, so let's go to stat edit, and we're going to type in the values from the table that's on our notes. So the x values are -4 on part A, -1, 5, 8. And then our y values in the table that's provided on part A is 48, 18, 12, 36. Now, I highly encourage you, your calculator is doing all the work for you, so I highly encourage you to always check and make sure that you entered all of your points in correctly. So just double checking, all of mine look good, so I'm going to go back to my home screen. And so now after we do stat edit, we're going to do stat, go over to calc, and then we are using quadratic regression, which is number 5. We want to calculate, press enter. Notice it gives you your A, your B, and your C. So we're going to plug those into our quadratic equation. So A is 1, B is -5, C is 12. So my quadratic equation would be y equals just x squared, because it's 1 for A, minus 5x plus 12. And we're just looking for that equation. Okay, so now I'm going to go to B. This time I'm given a graph. So we're going to plug in those points from the graph. So if it helps you, you're welcome to set up a table or just look at the graph. So 1, 9. 2, 4, 3, 1, 4, 0, 5, 1, 6, 4, and 7, 9. So those are the points we're going to plug in. So we're going to stat edit. You can go up to L2, press clear, not delete, and then go back down and it should clear out the list for you if you want it cleared. So our x values were 1, 2, 3, 4, 5, 6, and 7. Our y values that corresponded with those were 9, 4, 1, 0, 1, 4, and 9. Again, double check your points or your values that you entered in just to make sure that you typed them in correctly. We're going to go back to the home screen. So second quit, stat, calc, quadratic. Remember, we're doing quadratic. It's number 5. Calculate. We're given the A, B, and C. And so we're just going to substitute in for that. So our equation will be y equals x squared minus 8x plus 16. Okay, the next part. So we were given a table and a graph on A and B. Example 2, we're going to be given this word problem, and we're going to fill in and find those values. So the height of an object launched into the air in relation to time is modeled by the quadratic function. The object was spotted at, here's our data, 412 feet after 1 second from launching. So that's 1 point. Notice the time is our x, the height is our y. So I'm going to have a 1 and then 412. My next data point would be to 492, 8, 300, and the last one, 9, 156. Okay, so we are going to plug that in. So go to Stat Edit. Again, you can go up to the top, press clear, and then go up to the top, press clear. Okay, so our x values are 1, 2, 8, and 9. Our y values that correspond with that are 412, 492, 300, and 156. Just double check those numbers. We're going to find our function. So second quit, we're going to stat, calc, quadratic is 5. Okay, so there's my ABC. We're going to substitute it in to write our equation. So our equation will be y equals negative 16x squared plus 128x plus 300. So there's our quadratic equation. And then it says use your calculator to create a scatter plot of the data and then graph the regression equation that we just found on the same screen. So I'm going to go to, if you remember, go to y equals. Make sure everything in y equals is cleared out, and then we can go up, and when we are looking at plot 1, go ahead and press enter on it, and it should highlight it whenever you go back down. So that means your plot is turned on. Now, clearly, if you press graph, you're not going to be able to see all of your points. Okay, so you're going to have to adjust your window. So go to window. We know that the x min, we're only going to be looking at these positive values, so our x min would be 0. Looking at our table here, we know that our max was 9, so I'm just going to put 10 and see if this is going to be a good window. Instead of increasing by 1 to go to 10, I'm just going to increase by 2, but that scale really doesn't matter. Our y min, I'm going to go ahead and put 0. And then our y in the table, the max was 492, so I'm just going to say 500. And then we can always go back and adjust it if needed. The scale, I'm going to increase by 100. So the x and y scale, they do not have to match. Okay, so we should be looking at 4 points. Notice we do see 4 points. And then remember, you can also go to your y equals and insert that equation. Now, since this equation was no decimals, you can actually just go to it and type it in. Negative 16x squared plus 128x, and then plus 300. Compress graph. Okay, so the next part, it says on part C, we're going to just sketch this. So we're going to go to C and plot those points. Now I'm going to use the table that I set up. If you look at your window, we went from 0 to 10, increasing by 2 on the x. 2, 4, 6, 8, 10. And then we went from 0 to 500, increasing by 100. So 100, 200, 300, 400, 500. So we're going to plot those points that we have from our table. So that would be 1, 4, 12, 2, 4, 92, 3, or we don't have 3, so sorry, let's go back. go back. This was a 2. My bad. So you're going 1 for 12, 2 for 92, and then 8. 8 was at 300, and 9 was at 156. And if you look at your graph on your calculator, that line, it's going through those points. It goes up. We can't really see where it's going to. So we can't really see that top point. I did not draw a very good line. It needs to go through your 2 point or your 4 points. Okay, so we're using the regression equation to predict how much time will elapse between the launch and when the object hits the ground. So that would be when it hits the ground. That means the height, which if you look at your table, that's your y, would be 0. So we're finding when h is 0, which is this point here. Notice that is our x-intercept. So when we go back to our table, or go back to your y equals, we're going to plug in a 0 in for y2, and then we're going to use the intersection. So second, calc 5, enter, enter, enter. And notice it is intersecting the x-axis, so when y is 0 at 9.895. So we'll round to 3 decimal places. So we had to insert the 0 in y2, second, calc, and then number 5, enter 3 times. So that will find where it hits the ground. So that was at approximately 9.85, and we're 895, and we're looking at the time, so that would be in seconds. So if it's wanting you to figure out how long it will take to hit the ground, you know your y would be 0. Okay, so then when it says use the regression equation to determine the maximum height reached by the object. So maximum height, if you remember when we were talking about quadratics before, that's referring to your vertex. And then when did that object reach its max height? So height would be the y. So we're needing to find the vertex. Since my parabola I know looks like this, our vertex would be at the top, so that would be a max. So we've done this before. Now, if you go back to your calculator here, notice that we're not able to see that vertex point. So go back to your window and let's change our y max to something larger. So let's just say 600 and see if we're able to see. Notice now we're able to see that vertex point. So you might have to adjust. So I'm going to do second calc, and I'm going to choose maximum, which is number 4. We've done this before. We're going to go over to the left side of the vertex when it says left bound. And then right bound, go to the right side of the vertex. Press enter, and then enter one more time. It should say maximum once we have found it. So notice that our maximum would be 4 and then 556. So we are, so we went second calc, number 4 is max, and then we found that maximum point to be 556. So make sure you put it in words of what this means. So that means after 4 seconds, it will reach maximum height of 556 feet. Okay, so after you have plugged in your points, found your regression equation, then you're having to answer a few questions. So let's go back or to the back. We're going to be modeling square root functions using quadratic regression. So quadratic Regression may be used to model square root functions. If you remember, quadratics and square roots are inverses of each other. So this is what's going to happen. On the regression on the calculator, there is not a square root one. There's only a quadratic regression. So if you're given a square root, you're going to create a table of at least 3 points from your square root relationship. You're going to switch your x and y values to write the inverse, because remember, the inverse of a square root is a quadratic. Then you're going to perform quadratic regression, because when you switch those x's and y's, it becomes quadratic. You're going to write down the equation, and then you're going to find the inverse equation by switching x and y and solving for y. We're writing down the square root equation, and then we're going to use function notation. All right, so if you look at this, if we were to connect those, notice that looks like a square root graph. You have to know what square roots look like. So I'm going to make a table for my square root. So that would be 1, 0, 2, 1, 5, 2, and 10, 3. My inverse table, to find the inverse table, all you have to do is just switch x and y. So 0, 1, 1, 2, 2, 5, and 3, 10. Now I'm going to plug those into the calculator. I'm just going to clear everything else out in there. Go to Stat, go to Edit. I'm going to clear out my list. I'm plugging in my new table that I just found. So 0, 1, 2, 3. And then 1, 2, 5, 10. Again, just double check your numbers, make sure you typed them in. The reason I switched my x's and y's is because when you go to Stat, Calc, there is no square root regression. There's quadratic, so that's when we switched them. Go to Calculate, and then notice we found the A, B, and C. Notice here that our B is 0, which means we will not have an x in the middle. So whenever I find this, it's y equals x squared, because it was 1 for A and then 1 for C, so plus 1. The reason there's no x in the middle is because B equaled 0. Okay, so in order to find this equation, square root equation, we're going to write down our quadratic equation. That's the inverse of this. And remember, to find the inverse, we are switching x and y. We've done this before. We want to isolate the y. And then to get rid of the squared, we're taking the square root. Now, anytime I take the square root of both sides, I get a positive and a negative answer. But look at your graph. Notice my y values are not negative, so it's only using the positive values. So you'll only use the positive square root. And then you can rewrite it in function notation. And actually, this is not the inverse, so you don't have to put that negative one. Okay, so if you're given points that look like a square root function, write the points down, flip them, so switch them, find your quadratic regression, and then you can use that equation in order to switch x and y and actually find your inverse of that. If you have any questions on quadratic regression, please let me know.